Alright, so in this video, I'm going to be solving the equation x to the power of 3 is equal to x to the power of 5. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution, I'm going to rewrite my equation down here so I have a little more solving space. So my equation x to the power of 3 is equal to x to the power of 5. And what I'm first going to do is subtract x to the power of 5 on both sides. So these two cancel out, and I get x to the power of 3 minus x to the power of 5 is equal to 0. Now, from here, x to the power of 5 is the same thing as x to the power of 3 plus 2. And an important property of exponents is that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of 3 plus 2 is going to equal x to the power of 3 times x to the power of 2. And now I'm going to factor out x to the power of 3. So I get x to the power of 3 times 1 minus x squared. So now this gives me two equations. I get x to the power of 3 is equal to 0, and I get 1 minus x squared is equal to 0. So for x to the power of 3 equals 0, I'm going to take the cube root on both sides. So I get the cube root of x to the power of 3 is equal to the cube root of 0. The cube root of x to the power of 3 is x, and the cube root of 0 is 0. So x equals 0 is one solution. Now for 1 minus x squared equals 0, I'm going to rewrite this as negative x squared plus 1 is equal to 0. And now I'm going to multiply both sides by negative 1. So negative 1 times negative x squared plus 1 is equal to x squared minus 1. And 0 times negative 1 is 0. So I get x squared minus 1 equals 0. And 1 is the same thing as 1 squared. So I have x squared minus 1 squared is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So this is equal to x plus 1 times x minus 1 is equal to 0, meaning I get two equations, x plus 1 equals 0 and x minus 1 equals 0. For x plus 1 equals 0, I get x equals negative 1. And for x minus 1 equals 0, I get x equals 1. So notice how we have three equations for this equation. Notice how we have three solutions for this equation. Alright, so in this video, I'm going to be solving the equation x to the power of x to the power of 3 is equal to 729. So, to solve this, what I'm first going to do is take the power of 3 on both sides. So I get x to the power of x to the power of 3 to the power of 3 is equal to 729 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. Now, m times n, I can also rewrite as n times m. And if something in the form a to the power of m to the power of n is equal to a to the power of m times n, then a to the power of n times m should also equal to a to the power of n to the power of n. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of n. So now from here, I have x to the power of x to the power of 3 to the power of 3, and I can think of x to the power of 3 as m and 3 as n. So if I switch the places of these two, I get x to the power of 3 to the power of x to the power of 3. And remember, this is equal to 729 to the power of 3. Now, from here, I'm going to let x to the power of 3 equal to the variable y. So I get y to the power of y is equal to 729 to the power of 3. Now, I can simplify 729 to the power of 3. So 729 is the same thing as, 729, let's find some factors of this. So a factor of 729, let's try to divide this by 3. 729 divided by 3, we have 2 over here, so we get 6. We subtract 7 with 6, we get 1. We bring that to 2. 3 times 4 is 12. And now we bring that to 9. 3 times 3 is 9. So I get 729 is equal to 243 times 3. Now, 243, if I divide this by 3, I get 81. So I have this times 3 times 81, I have 3 times 3 times 81, and 81 is the same thing as 3 to the power of 4. So I have 3 times 3 times 3 to the power of 4, which is equal to 3 to the power of 6, meaning 729 is the same thing as 3 to the power of 6. And 3 to the power of 6, I can break that down into 3 squared times 3 squared times 3 squared, which is equal to 9 to the power of 3. So I'm going to replace 9 to the power of 3 with 729. So I get y to the power of y is equal to 9 to the power of 3 to the power of 3. And the reason I did this is because 9 to the power of 3 to the power of 3 is the same thing as 9 to the power of 3 times 3. And 3 times 3 is 9. So I get y to the power of y is equal to 9 to the power of 9. And now I can use the property a to the power of a is equal to, if a to the power of a is equal to b to the power of b, this means that a equals b. So in this case, y is equal to 9. Now, recall how I let x to the power of 3 equal to y. Meaning, I get x to the power of 3 is equal to 9. So now to solve this, I'm going to take the cube root on both sides. So I get the cube root of x to the power of 3 is equal to the cube root of 9. Now the cube root of x to the power of 3 is simply just x. So I get x is equal to the cube root of 9. And this is the same thing as 9 to the power of 1/3.